concentrate on how to crack the questions related to speed, distance, and time in a placement drives. Now we'll recall some of the key points. So in the entire session, I'll consider speed as S, distance as D, and time as T. And we know the basic relation that speed equal to distance by time. We all of us know the basic relation between speed, distance and the time. But we need to remember some of the key points. Now suppose two objects are moving at a speed s1 and s2. Two objects are moving in a speed s1 and s2 such that its ratio s1 by s2 equal to a by b. Two objects are moving at a speed of s1 and s2 such that its ratios is equal to a by b. Now, to cover the same distance, if both the objects covers the same distance, then the ratio of time taken by both the objects t1 by t2 is equal to b by a. Okay, so if the two objects moving at a speed of s1 by s2 such a way that it is in the ratio a by b, then time taken by two objects to cover the same distance is in the ratio b by a. How is this? So t1 by t2 equal to, what is t1? Now this speed is equal to distance by time. So what is time is equal to? Time is equal to distance by speed. So this t equal to d by s. So this t1 becomes d by s1 and this t2 becomes d by s2. Since the distance remains the same, it becomes s2 by s1, which is equal to b by a. So while solving the problem, we need to remember this point. Another one, this is the first point. Second point is about average speed. Average speed comes when an object covers different distance in different interval of time. That means suppose an object moves a distance d1 in a time t1 and later it covers a distance of d2 in time t2 such a way that till dn equal in a time distance dn in time tn, then average speed to cover the distance this to this, average speed of the object is equal to total distance by total time. So total distance by total time. Now next, third point. Now suppose two objects are moving at a speed of s1 and s2 to cover a constant distance. To cover a constant distance. So two objects are moving in a speed of s1 and s2 to cover a constant distance, then average speed equal to 2s1 s2 divided by s1 plus s2. Okay, so when two objects are moving in a speed s1 and s2 to cover a constant distance, then average speed is 2s1 s2 by s1 plus s2. Now next point. Similar to the third one, two objects are moving in a speed s1 and s2 for a constant time t, for a constant duration. So two objects are moving in a speed of s1 and s2 for a constant duration, time, then average speed equal to s1 plus s2 by 2. Okay, when two objects are moving in a speed s1 and s2 for a constant duration, then average speed is equal to s1 plus s2 by 2. Okay, then point number 5. Point number 5. Two objects moving at a speed s1 and s2. When two objects moving in a speed s1 and s2 in opposite direction, then relative speed equal to s1 plus s2. Now the question is, what is the relative speed? Relative speed, or it can be called as effective speed. Now concentrate here. When one train or one object is moving in this particular direction and one object in this particular direction, opposite to each other, in a speed of s1 and s2, to cover a shortest small distance, in what time it will cross this particular point or something like this. So in that case, instead of calculating the time taken by this as well as time taken by the another object, we will consider a concept of relative speed. Means both are approaching the object. The speed at which it is approaching the object is sum of the speeds. So that is why relative speed of two objects which are moving in opposite direction in a speed s1 and s2, then relative speed becomes s1 plus s2. Now, sixth one is similar to this. The two objects are moving in same direction at a speed of s1 and s2. Two objects are moving at a speed of s1 and s2 in same direction for a constant distance. In both these cases, the distance is constant. Then relative speed equal to s1 difference s2. Difference of s1 and s2. It can be s1 minus s2 if s1 is greater than s2, or it may be S2 minus S1 depending on the situation. Okay, relative speed concepts, average speed under two different conditions, then speed. And one more very important thing is conversions. That is kmph, kilometer per hour to meter per second. So 1 kilometer per hour equal to 1 kilometer means 1000 meters, 1 hour means 3600 seconds. So it is 5 by 18 meter per second. So 1 kmph is equal to 5 by 18 meter per second. Similarly, MPS, meter per second to kmph. So 1 meter per second equal to 1 meter is equal to how many kilometer? 10 to the power minus 3 kilometers, and 1 second is equal to 1 by 3600 hour. 1 second. So it becomes 3600 by 1000, or it is 18 by 5 kmph. So these are the some of the 7 key points you should remember while cracking the question. Okay, so now we'll start solving some of the questions appeared in TCS placement track, earlier placement test, NQT test. Now, first question. A bus leaves Mumbai at 3 pm. It travels for 1.5 hours at 60 km per hour and then halts for 30 minutes. It then travels at an average speed of 50 km per hour for the remaining duration to reach Pune at 6 pm. What is the distance between Mumbai and Pune? So what is given? You have Mumbai 3 pm. So it will travels towards Pune for 1.5 hours at a speed of 60 kmph. So what is the distance traveled during this 1.5 hours? It is 1.5 time into speed 60, that means 90 km. So it halts for travels a distance of 90 km. Then it halts for 30 minutes. Then it travels from this point, means 1.5 hour minutes is the 4:30. Then halts for 30 minutes. So 5 o'clock, 5 pm it leaves from this point, and then it will take a journey such a way that it will reach Pune at 6 pm. So what is the time taken to reach the Pune after the halt? This is the 1 hour. Correct? So what is the speed at this duration? So it is average speed is given as 50 km per hour. So what is the distance traveled in this? It is 50 into 1 hour. Duration is 1, time is 1. So it is 50 km. So what is the total distance between Pune and Mumbai? 90 plus 50. So 90 plus 50 equal to 140 kilometers. Okay. Okay, we will move to the next question. Now, read this. A fast train takes 3 hours less than a slow train for a journey of 600 kilometers. So a fast train takes 3 hours less than slow train for a journey of 600 kilometers. If the speed of the slow train is 10 kilometers per hour less than that of the fast train, the speeds of the two trains are. So I'll consider the speed of the fast train as s. If I consider the speed of the fast train is s, what is the speed of the slow train? S minus 10. S minus 10. This is the fast train, this is the slow train. Speeds. Now, what is given? A fast train takes 3 hours less than the slow train. So, slow train takes more time. So, what is the time and speed relation? Distance is the same. So, 600 by s minus 10. So, this is the time taken by slow train minus 600. Distance is given as 600 km divided by s equal to 3. Correct? Time taken by slow train minus time taken by the fast train is equal to 3. So if I simplify and solve, I get s. So I have to simplify. So LCM, so 600s minus 600 into s minus 10 equal to 3 into s into s minus 10. 3 into s minus 10. So 600s gets cancelled. So 6000 equal to 3s square minus 300s. So if I take 3 outside, so I will get 2000 equal to s square minus 100s. So quadratic form, s square minus 100s minus 2000 equal to 0. Sorry, this is not a 300, this is the 30, or it becomes a 10. Not a 100, it is a 10. So what are the factors? S minus 50, S plus 40. So S equal to 50. So speed of the fast train is 50. So speed of the slow train is S minus 10. That is 40 kmph. This is 50 kmph. Okay, we'll move to the next question. Now, a car travels 25 km an hour faster than a bus for a journey of 500 km. If the bus takes 10 hours more than that of car, then the speeds of the bus and car are. It is similar to the previous problem. What is given here? A car travels 25 km an hour faster than the bus. So, if the bus speed is s, bus speed I will assume as s, then car speed is s plus 25. Correct? So, car travels 25 km an hour faster than a bus. So, what is the total distance it is given? Journey is given as 500 km total distance. Now, what is given? If bus takes 10 hours more than the car. So, what is the time taken by bus to cover this distance? That is as 500 distance by speed minus 500 by s plus 25 equal to 10. Correct? Now s into s plus 25 LCM equal to 500 into s plus 25 minus 500s equal to 10. So 500s gets cancelled. 500 into 25 equal to 10 into s into s plus 25. So 1 goes cancelled. So it becomes s square plus 25s minus 1250 equal to 0. So it becomes s square, factors are s plus 50 s minus 25. So you will get two answers, s is equal to minus 50 and plus 25. The speed cannot be negative, so this is not the answer. So speed of the bus is 25 km per hour. So then what is the speed of the car? Speed of the car is s plus 25. That means 50 kmph. Any questions? No. Okay, we will move to the next one. Now, a goods train leaves a station at a certain time and at a fixed speed. After 10 hours, an express train leaves the same station and moves in the same direction at a uniform speed of 90 km per hour. This train catches up the goods train in 4 hours. Find the speed of the goods train. First, try to analyze the concept. Now, here is the point. I'll assume goods train leaves the station, right? It is running at some speed. Let it be s. Okay. Now, after 10 hours, which moves in the after express train. After 10 hours, express train. So by that time, this has traveled a distance in 10 hours. Okay. So this is the speed at the goods train travels at a speed of s for 10 hours. At that time, this express train, goods train, express train. This express train starts from this. Now, the speed of this express train is given as 90 km per hour. So, after 4 hours of journey, means after leaving from this point, 4 hours of journey, it meets the goods train. That means from this point it will also travel a 4 hours plus 4 hours. That time express train will meet the goods train. So what it means? So express train, distance travelled by express train in a 4 hours is the same as distance travelled by goods train in 14 hours. Am I right? So distance travelled by express train in 4 hours is equal to distance travelled by goods train in 14 hours. So what is the distance travelled if it is equal? distance traveled by goods train is what? Speed into time. So S into 14 equal to S into 14 because it travels for 14 hours equal to speed of the express train is 90 into 4. 90 into 4. So what is S is equal to 90 into 4 divided by 14. So it comes around 360 by 14. That is 360. 1, 362, 14 twos are 28, 80, 80 means 5, 70, 10 means 7 kmph. 25.7 kilometer per hour. So 25.7 into 14 equal to 360. So this is the speed of the goods train. Next. A road network covers some cities. City C can be reached only from the city A or city B. Now, what is it given? Some city C, city A and B. So there is a reach from city A as well as city B. Okay. The distance from A to C is 65 km. So this distance is A to C is 65 km. And that from B to C is 30 km. So this is 30 km. The shortest distance from A to B, the shortest distance, so there may be many paths, but the shortest distance is 58 km. The shortest distance from city P to A, some city P, from this point, shortest distance to A is 420 km. The shortest distance from city P to B is 345 km. So this distance is given as 345 km. So the shortest distance from city P to city C in kilometers is. Now while reading this question, it looks like complicated. From city A to C, A to B, B to C, something like that. But if you represent these questions in a mathematical graphical form, as I did here, now it becomes easy. Now what is the question? The shortest distance from city P to city C. So this distance, now this is from P to A. What is the possible distance? 420. A to C, 65. So total is 485. So if I go through this, 420 plus 58 plus 30, so it is 88, 508. So if I travel this is the shortest distance. So shortest distance from P to C is 345 plus 30. So 375 km. This is a very simple but a tricky. Now, two trains 137 meters and 163 meters in length are running towards each other. So two trains running towards each other. The length of the train is 137 meter and 163 meters. Okay. In a parallel line, on a parallel line. One at rate of 42 km per hour, another at rate of 48 km per hour. So this speed is 42 kmph and this is 48 kmph. In what time they will they be clear each other from the moment they meet? Now here these two trains meeting in the sense face to face meeting. Starting point of both the trains are in opposite direction. Now ending means both the tail portion of the trains should cross each other. That means total distance travelled is distance of the trains. So total distance to be travelled to cross each other. To be travelled to cross each other. Cross each other. That is 137 plus 163. That means 300 meters. Now, since both the trains are in opposite direction, I will consider the relative speed. So, or it is called an effective speed, as I told in the concepts, key points. Relative speed is what happens? 42 plus 48. That means 90 kmph. So speed is in kilometer per hour and the distance is very small, 300 meter. So I need to convert this kmph to mps. So while converting kmph to mps, this is multiplied by 5 by 18. So it is 25 mps, 25 meter per second. Now, in what time they will clear each other? So, time to cross. So, what is the time to cross each other? Distance by speed. So, distance is 300 meter and speed in mps is 25. So, it will take 12 seconds. So, as the unit of the distance is in meters and I need to convert the speed from kmph to mps. So, time taken by the trains to cross each other is 12 seconds. Next, a man sitting in a train. A man sitting in a train which is travelling at 50 kmph observes that a goods train travelling in opposite direction takes 9 seconds to pass it. If the goods train is 280 meter long, find its speed. Now what happens? Now a train. So in the train, one person is sitting somewhere here. So a man is sitting in a train. Now this entire train is running at a speed of 50 kmph. Correct? Now a goods train comes in an opposite direction. And this goods train crosses this person in 9 seconds. So in the 9 seconds, this train is also moving in this direction, as well as goods train is moving in opposite direction. So instead of considering the effect of the passenger train and goods train separately, we will consider the effect in terms of relative speed. And what is the distance to be travelled? So in 9 seconds, which distance is covered? So here in the question, In 9 seconds, goods train passes him in 9 seconds. So the length of the goods train is the distance which is to be observed by the person. So distance is 280 meters. 280 meter long train. And speed of the passenger train is given as 50 kilometer and the speed of the goods train which is to be calculated. So I will consider the speed of the goods train. Speed of the goods train as S. So since goods train and the passenger train are in opposite direction, what happens to the relative speed? Relative speed is S plus 50 kmph. But the distance is in 280 meters. So I need to convert this relative speed into meter per second, MPS. So S plus 50 into 5 by 18. Now 280 and this next. So distance is 280 and relative speed is S plus 50 into 5 by 18. So what is given? The time taken by to cross the goods train is 9 seconds. That is speed by time. Sorry, distance by speed. That is 280 divided by 5 by 18 into S plus 50 distance by speed in meter per second equal to 9. So if I take it the other side, 280 equal to 9 into 5 by 18 S plus 50. So 9 ones are 9 twos are. So what happens this equation? 560, 280 into 2, 560 equal to 5s plus 250. So S is equal to 260 minus 250 is 310 by 5 equal to 62 kmph. So speed of the goods train is 62 kilometer per hour. So it is whenever you are solving a question in a speed, distance and time, better to put it in a form of graphs or drawing, mathematical modeling or mathematical expression, then it is easy to find the solution. So read the question carefully and then try to analyze the things. Thank you. To learn more aptitude cracking techniques, subscribe the channel Sambodhana. Thank you.